My name is Bill Alcock. One minor correction. The AIG is considered part of the operations group, but we are not traditional sysadmins. All right, so before we get started, one thing I want to talk about is the fact that a lot of what we're going to talk about are plans, right? We do not yet currently have a machine in production running PBS. I have PBS running in VMs on my laptop. So that's where the experience has mostly come from. And we do have one test machine internally. But so, this is what we believe to be true or what we plan on doing. So just be aware of that. And we're also, the machines that so all machines going forward will be PBS based. That is Polaris, which should be coming online, this summer, fall. And then we're going to replace Cooley, which is our current Viz cluster, and with a new Viz cluster, which will be coming online fall, early winter. And both of those will run PBS. Aurora will run PBS when it comes online, and so on and so forth. But again, the gist here, this is all subject to change. So be aware of that. All right. So first, just, some tools and things to help you in this transition. Throughout the presentation, I give section references and page numbers. Those all refer to the 2020 PBS Pro documentation, which is this link right here. So, just be aware of that. And by the way, I am assuming that all of you have most of you have run here at ALCF with Cobalt, and if not, you have run a batch scheduler of some kind somewhere. If that's not the case, and I lose you, feel free to stop me and ask for clarification on something. So if any of you have ever used AIX or any of the older kind of Unix variants, going from Cobalt to PBS is going to be kind of going between Linux and AIX. You're going to know the command that you want, QSub, QStat, QDEL, all that kind of stuff. But differences in command line options are going to throw you. It's like, oh, wait a minute, that doesn't work anymore. So what do you do about that? Well, there are two kind of tools that we've provided for you. So one of the big advantages of this transition is, Cobalt did not have good documentation. I'm the lead, I'm responsible for that. I admit it. PBS has outstanding documentation. There's about 2,000 pages of it, and it is quite good. There is what they call the big book, which has all of them, and they're broken into guides. And the two that will be of interest to you are the user guide and the reference guide. And that's what I make reference to throughout the presentation. There's also a document that we've produced. The link is in the chat. And it's just a PDF that says, okay, if you used this Cobalt command line, here's how you get to the equivalent in PBS. You'll see some of those in the presentation. I don't cover them all. If you're glancing through that, you see something that I don't cover that you want to ask questions about, feel free to hit that up at the end of the presentation. And then finally, we also developed a tool called QSub to PBS. It is currently deployed on all, it's on Cooley, it's on Theta. And so you should be able to take any QSub command that you issue, bring it back, change it to QSub to PBS, and it should then spit out the equivalent PBS command line. And if you want, instead of a command line, you want a script, just add the -- directives option, and it should then spit out with, the appropriate script directives and so on and so forth. All right. So some high-level concepts. You're going to hear two terms out in the world. One is OpenPBS, the other one, or PBS Pro or just plain PBS. So OpenPBS is an open source project, and we are contributing to that. PBS Pro is OpenPBS with some more extensive hardening and testing. You get paid priority support. They add some optional features like an accounting system. We won't be using that accounting system because we have our own. And some people worry about, how different is it? Every time they do a PBS Pro release, it starts from the OpenPBS master branch. So it's not a crippled version. The open one's not crippled or anything. It's just there are additional features that they, keep separate, and none of them are particularly critical to us. So you're going to hear me when I give this presentation. I'm probably going to say the word node out of habit, but everything in PBS refers to a vNode and or a virtual node. That may well be equivalent to the physical node, and in ALCF, it's likely that is going to be true, but it doesn't have to be. And so, as an example, for those of you who are familiar with Theta GPU, those are running NVIDIA DGX nodes, which have 8 GPUs in them. And if we were running PBS on Theta GPU, we are not, but if we were, we could choose to, if we wanted to carve that DGX node up into 8 vNodes, where each vNode had 1 GPU, 1/8 of the cores, 1/8 of the memory. Or we don't have to divide it evenly, right? We could divide it any way we want to. But that's the concept of a vNode. But all commands, all scheduling, everything is done against vNodes. And I'm just going to use the term node and vNode interchangeably. So a big difference between what we plan to do with PBS and how Cobalt has worked is, with Cobalt, we had a different Cobalt instance on every system. So there was a Cobalt instance for Theta, there's a Cobalt instance for Theta GPU, there's a Cobalt instance for Cooley. And with PBS, there is an option to have, one scheduler that, to rule them all, that covers the entire facility, and that is what we are planning on doing. However, when all said and done, it's going to be a lot of nodes. So we haven't tested this at scale, so we don't know how that's going to work. But we would like to do that because there are some advantages to it. Okay, so I'm going to spend the vast majority of this presentation talking about QSub. And the reason for that is where most of the differences lie. And that's the thing that's, the most complicated, the thing that you do the most, different things with. So it has the same function as in Cobalt. It puts a job into the queue to be executed. The biggest difference is in how you indicate where you want to run. So in Cobalt, again, I said we had an instance on every system. And our systems tended to be homogeneous. So it was kind of known, right? I'm running on Theta. I submit a job. It's going to run on Theta. And if there was some heterogeneity, we generally handled that with queues. So if there were, like Cooley at one point had some big memory nodes, and they sat in a separate queue called Big Mem. And that's how you would indicate that you wanted to run on those. You'd put your job into the Big Mem queue. In PBS, there is, and I'm using SQL like very loosely, but there's a select syntax for saying, here's the characteristics that the resource needs to have in order for me to run. This is aimed at kind of more distributed, I'll use the term grid or cloud type systems where you're saying, I don't care where I run as long as it's an x86 architecture with this much memory, this kind of a GPU, this much disk space, whatever. And you're probably not going to need that to do that in ALCF because, again, our systems tend to be homogeneous. But you still have to use that select syntax. Okay, and this is covered in the user guide section 4.3. And it's not obvious because of the font, but the selections are done with a minus lowercase l. So sometimes it looks like it's an L, sometimes it looks like an I, but it is minus lowercase l. And when you make these selections, there are two types of resources, or two classes of resources, maybe is the better way to say it. One is a job-wide resource, and an example of that is the wall time, right? Some nodes don't run for different wall time. And so to get a wall time, you just say minus L, and then in this case, it's wall time equals hours, minutes, seconds. But then there are things that they refer to as chunks. That's their term. And so the nodes, because you could be asking for nodes with different characteristics. And so the format of that is, again, it's a minus L, but then you use the keyword select. And then you say a number, how many of those do I want, a colon, and then you list the characteristics that you want to have. So we are going to create, we plan to create what's called a custom resource called system. And each node will have that custom resource, and it will be assigned whatever the system name is. So all the Polaris nodes will have a system equal Polaris, and all the Cooley 2 nodes, we're not going to call it Cooley 2, but we haven't named it yet. So we'll have that. And so that's probably going to be the easiest way for you to do your selections. So let's say we do have this one scheduler to rule them all, and you wanted 128 nodes on Polaris to do your simulation, and then you wanted 8 nodes on the Viz thing to do some visualization or analysis, and they needed to talk to each other, so they needed to be running together. It would look like, so minus L select, and then you say 8 colon system equals Cooley 2, so I need 8 nodes on Cooley 2, and then 128 colon system equal Polaris. And then that would get you, what is that, 136 nodes, 8 on Cooley, 128 on Polaris. There are a huge number of built-in resources in PBS. I'm not even going to begin to go over them, but if you look in the reference guide, section 5.6, then you can see them. I mean, it's many pages long, the list. And I don't know, maybe if people are interested in looking at the documentation, since I don't think they could click on that, Ray, if you want to grab that URL and put it in the chat so people could look at the doc if they want to. And so I am guessing that you probably are not going to need anything other than the system equal. But you could use it, and it should, like for instance, if you say it's got to have 64 gig of RAM, if you put that mem equals 64 gig, then you won't run anything that doesn't have that. But again, all the nodes are going to be identical, so probably isn't necessary. And there at the bottom, so a minimal QSub would look like, QSub minus A, you still got to specify your project so we can charge the job, minus L wall time, and this one, I set it for an hour, and then minus L select, and I said I want 128 nodes on Polaris, and then that's, dash A dot out. And so if you want to actually run an executable, you have to use that dash syntax. Otherwise, if it's a script, you just put the script out there on the end. To be clear, PBS would allow you to literally say QSub space script. It will default to a single node, and it will default to infinite time. We won't allow that. So we will put custom configurations in so that you will be required to specify the project. You will be required to set a wall time, and you will be required to request a number of nodes. And now that I think about it, I don't know if we do have it running across the entire facility, I don't know what it would default to in terms of which system it would run it on. But again, we're not going to allow it to run that way anyway, so it doesn't matter. All right, before we go on, just I mean, I kind of went through a bunch of stuff. Any questions right now? Anything that isn't clear?
I just wanted to check that I understand the sort of chunk syntax. So anything, so basically is the select keyword the thing that anything following that refers to a chunk?
Yes.
Okay. I just wanted to make sure that was the actual connection between the syntax and the concept. Okay, I think I get it.
Okay. Anything else? All right, moving on. Okay, so some more QSub differences. There is a table in the user's guide that basically has a list of all of the options and then a link to where in the documentation it covers that option. That's very handy. So, that's one you're going to want to have handy if you're actively trying to make a QSub run. The way you move environment variables. So in Cobalt, we had, minus env, and then you gave a list of attribute value, environment equals. And in PBS, you use minus v and the same basic syntax, environment equals. Or there is an minus uppercase v, in which case it will copy every environment variable in the QSub environment into the compute node environment. I'm not sure I would use that one personally, but it is there. So one of the differences that it's probably more of a big deal to us as developers and admins than it is to you is in Cobalt, we passed attributes into the server. And so that's how pubnet works, right? You say minus adders pubnet, and that would tell us that you wanted external connectivity, and then we would spin up the external NICs and all that kind of stuff. And we keep, because our mindset is that way, we keep trying to use that. But in PBS, server attributes are admin only and are specifically about running the server. So in PBS, what we would have to do is node, like for instance, using pubnet again as the example, nodes that have external interfaces, again, we would have to create a custom resource called pubnet on those nodes. And then you would say minus L select, how many nodes you want. And then, you'd say pubnet equals true. And I guess that's not complete because it would also have to say system equals, whatever. So it knew what system to run it on. But that's how we'll do things like pubnet and various other things. Dependencies, again, they were fairly similar. In Cobalt, it was minus dependencies and then, list of job IDs. In PBS, it's minus W depend equal. And then they have a lot more options for what the status of the job is. So for us in Cobalt, the only thing it was the job had to complete successfully. And the equivalent to that is after OK in PBS. But there's after, which is, success or failure. There's after OK. There's after not OK, which means only run this job if that one failed. There's a bunch of before options. And again, there's a reference there for where you can look those up to see what they all are. Getting email, again, fairly similar. So in Cobalt, it was minus M or minus notify, and then a list of email addresses. So PBS, you have to actually give it two options. One is minus M, just like Cobalt, with addresses, so that's the same. But you also have to specify a minus lowercase m and then what they call mail points. And to get the equivalent of Cobalt, which is mail when it starts and mail when it completes, you would specify BE for beginning and end. But there are other options, which again, there's a reference there that you can go look at. And then, of course, there are a bunch of capabilities. that PBS has that Cobalt did not have. A few of the ones that I think will be of interest, job arrays. So if you've got, parameter sweep to do, and you're going to run the same executable on, 10,000 times just with different inputs, you can create 10,000 input files, numbered 1 through 10,000, and then put a job array of 10,000 in, and it'll, run those. The main reason to do this, it's good for the scheduler. You're gonna, the scheduler is going to be more performant with one job array than with 10,000 separate jobs. But they do run as, the sub jobs are treated like jobs when it comes to running. And again, we haven't tried this out yet. We ran a couple of test jobs, so we're going to have some learning to do. I'm sure there are going to be, corner cases and caveats that we're going to have to figure out. So unless this has some kind of an unexpected result on scheduling, we're, likely going to enable job arrays. And then there's the ability to rerun a job. And this one I find interesting because there's sometimes when it does make absolute sense. We had an issue the other day on Crux, which is the test machine, and there were some nodes down, and for some reason PBS didn't know that. That's something we're looking into. But so we were trying to run a job, and the job was failing because it was trying to run on nodes that were down, and then PBS just automatically requeued it and then retried it again. So in an instance where it failed before it actually started, and that can be, dead node, that could be, it couldn't be routed for some reason because of policy or something, it'll requeue it, and that I think could be potentially useful. But there are instances, by default, it will assume that your job can be restarted. To prevent that, there's a, rerunnable flag or, not rerunnable flag on there. I think we are probably going to default that to be true, that, not rerunnable. And if your job is rerunnable, you can explicitly say that. But again, that's one we have to play with, but could come in handy. One I'm sure everybody's going to like. PBS, you can have job history. You're in Cobalt. Once your job was complete, it disappeared from QStat. You couldn't get any history on it. In PBS, that is not true. It remains visible. And we can set a time to live, a timeout, and its default is 2 weeks, and that's probably where we'll start. And then that can be adjusted based on user demand versus what it does in terms of server load and database size and, all that kind of stuff. And again, there are many more. So I am curious what people think about, job arrays and the ability to rerun. Would those be useful features?
I just wanted to, I guess, ask a clarifying question about the job array. So a job array, can I think about that as like a series of very similar QSubs, not a series of very similar like app runs within one QSub?
That is, yeah. So
Okay.
from QSub's perspective, the sub jobs are treated as jobs.
Okay.
And there are caveats in the documentation and so like some commands you can address to a sub job, some commands can only affect the entire job.
Okay.
And I quite honestly, I don't understand all of those caveats yet.
Okay, so this is sort of like I just submit one QSub and then it puts like a series of virtual jobs into the queue for me.
Yeah, conceptually, yes.
Okay.
So it looks like each subjob will be executed by a separate EPROM. Is that correct?
I believe that to be true, but I haven't tested it.
Yeah, in that case, we had such experience on Blue Waters at NCSA. It loads schedule. It makes a tremendous load on scheduler, and at that time we decided to disable that feature because of just scheduling becomes extremely slow. Typical what would be expected for job arrays is running some kind of bundling, either Balsam through Balsam or through other bundling systems. So the ability to run job array on a big machine like Aurora requires very careful consideration.
And that's why I said this is all subject to change. Yeah, I mean, the first thing we'll do is we'll test it and see what it appears to be, and if it causes obvious problems, yes, we will also disable it. But I was just curious, in terms of use cases for users, how many people actually have a need for something like this? And maybe this isn't the right forum to take a vote. So,
from my personal experience, it's just a very limited number of users who really need job arrays, and in most cases, they can do that job through a different means. That's what I've seen in my practice.
Okay.
Yeah, I guess that we might. There might be some cases for the automatic rerunning. I think I want to know a little bit more about exactly how it works and exactly how it knows when to stop. Hey, like, does it just stop when there's finally a successful job completion?
I believe, again, I believe the answer is it will continue to try indefinitely unless you throw an option which tells it how many times to retry.
Okay.
And we can and almost certainly would. It is my understanding that any option we can throw if you don't specify it, we can throw a default. And so we would probably do that. We would throw some kind of, 3 tries, 5 tries, something like that, onto it by default.
Yeah, I'll try to think about these cases. I don't have any like immediate obvious use cases, but these are interesting options.
Yeah.
From the previous slide, I'm super interested in the different conditions for dependency chaining. That sounds great.
Okay. All right. Anything else, or shall we move on? Okay. So there are a few capabilities that Cobalt had that PBS does not. One of them is on the CLI. You could throw the -CWD and set your working directory. You can't change that from the command line in PBS. So if you have a need to do that, you have to run a script and then just do the CD in your script. Another one is a user list. So Cobalt had the ability, I could submit a job, but then, I could say, Sue and Bob and Jane can also manipulate this job. Now it's in the scheduler, so they can queue alter, queue del, queue hold, things like that. It's the job is going to run as whoever submitted it. It's just who can manipulate the job in the scheduler. So they do not have that option. If there's a demand for it, we had a project along, 5-10 years ago, who had a real need for this because they ran 24/7 and they had people assigned on shifts to monitor. And so they needed to have multiple people who could manipulate the jobs. If there's a demand for it, we could add this feature to PBS. And then the other thing is there is no equivalent to the Cobalt log, the .cobalt file in PBS. And that was useful to us. I don't know if users made much use of it or not, but it's not there. And so, just in general, we are contributing to the open source project, and we can add features. On the last slide, when I talk about reservations, you'll actually see, we'll talk about some of the features that we intend to add there. So if there's a significant demand for it, we can add features to PBS. And which is, by the way, which is one of the main reasons we chose to go with them, because they were real open about accepting that sort of stuff. Okay, and then there are other commands, obviously, and they're mostly the same. Although there are a couple additional ones that seem like they will be quite handy. So QStat is QStat. I mean, if you're parsing the output, you're going to have to rewrite it, right? Because the QStat output's not going to look the same as it did from Cobalt. And by the way, something we ran into, and we were like, what in the heck is going on here? And then PBS has default column widths. And if your output is longer than the column width, by default, it just truncates it to make their columns stay nice and pretty and aligned. That is obviously problematic if you want to either parse it, or if everything starts with the same and the identifying information that differentiates them is out at the end. But there is a -JSON option, which A, would be easier to parse, and B, does not truncate. So if that's a need for you, add -JSON. And I believe, again, I haven't gone through and checked every option, but I believe all the commands have that option. But again, functionally, it does the same thing. QStat does the same thing. Same with QAlter, QDel, QHold, QMove, QRelease. If you put a hold on a job, you can release it with QRelease. These last two are different. We had no equivalent in Cobalt, and they seem like they could be quite useful. So QSelect, it allows you to query. It's a kind of it's a way to get a list of job IDs that meet a set of criteria, which you could then feed to something like QStat or something. So user, project, you can select on all that stuff. And so that seems like that could be very useful. Again, haven't tried it much, so we don't know what the limitations of it are yet, but it is there. And then trace job, we have been using that. That's quite handy. Basically what it does is it goes and extracts everything about your job from all the various logs. We really, really hope that we can enable that. We have to check something because it grabs everything. So we got to make sure that there isn't information that doesn't end up there that shouldn't. But we've been using it. It is quite handy. All right. Any other questions so far?
Yes, a question about QAlter. Are you considering to have it available to the users? If I remember, it allows changing wall time.
Yes.
So user it can be used to game the scheduler, so user can keep running job longer than the queue limit.
We had QAlter available on Cobalt, and we had code in there that would slap your wrist if you tried to game the system.
Okay, as long as it's under control, that's fine.
Yeah. So yes, a favorite user trick for a while was to make it look like their job. So I'm assuming you guys are running. If I say, prod long versus prod short, if you have a small, long job, you get less priority. It takes you much longer to run. And for a while, what people would do is they would say that it was small and short and accrue priority in the short queue, and then QAlter it into the queue long, so it got moved into the queue long queue. And then we basically added code that said, if you QAlter it and it moves you from one queue into another, you start over accruing priority, and that stopped people from doing that quite quickly. But yes, we do intend to have it because things happen, right? People make mistakes, things change. Particularly where we've seen it useful is if people have a chain of jobs and they have to change. It's like, oh, something went wrong. Here, change this. They can go in and change which executable it's running. things. So yes, we do intend to use it. It's been available on Cobalt. Other than the example I gave you, haven't seen much problem with it.
Yeah, I was gonna say from the scheduling side, like I think the benefits of QAlter have outweighed the downsides. Like we occasionally have to go and ask people to knock some stuff off, but generally it actually the experience is also pretty good on data.
Other questions or comments? All right. Okay, so reservations. Conceptually, they're similar, right? One, our policies are likely to be the same. No policies have been set, so for these new machines yet. So that's still subject to change, but I'm guessing that they're going to be quite similar, which is reservations are the exception, not the rule. We would much prefer that you get through through the queues if you possibly can. And again, like we've done in the past, we hope that we have the queue policy so that just happens. If it doesn't, we can, help you get through the queues. But if it's warranted, we can also give you a reservation. Some of you may have worked on PBS. PBS has the ability to let users set their own reservations. That's going to be disabled. And I honestly, I cannot fathom how that would work. Otherwise, the entire machine would be scheduled out to the end of time. And reservations are one of the places that I think actually Cobalt is better. Because the way we work in Cobalt is a reservation and a queue are two separate first-class objects. And then when we make a reservation, we just bind them together. And if you don't specify one, we create one for you automatically, but you can, say, use this queue over here in this reservation. In PBS, you can't do that. The queue is physically part of the reservation, and so its lifetime is that of the reservation, and that causes some potential problems. So one, when the reservation ends, the queue vanishes. So if there were any jobs left in the queue that didn't get through, they go away, and that can be annoying. The other thing that happens is if there are jobs running when the reservation ends, they will be deleted. So this is an area that we intend to make contributions. We're already working on the design, and it'll be our first kind of quality of life contribution to PBS. We are going to allow, so one of the things we have about working with PBS is they have it's been around for 25, 30 years. And they have they have a code base or a customer base out there. And so we can't break anything. But in this case, what we're going to do is add options. And so one option will be if you specify a queue, it will use it. Otherwise, it will behave as it does today. And we're going to add an option that says do not kill the jobs. And then if you don't specify the option, it will behave as it does today. That way we don't break anybody else's functionality, but we can get the functionality that we want. There is an interesting option to turn a running job into a reservation. We're going to play with that and see, again, the good versus the bad. So I can imagine that if you were debugging at scale and the problem was at scale, so you couldn't do it through the debug queues or something, then this would keep you from having to run through the queue again, right? We could grant you the ability to turn that job into a reservation, and then it could fail and you could restart. So that could be useful, but of course then a large chunk of the machine is sitting idle while you're doing debugging, which is bad. But we are gonna look at that and see how it looks.